I'll send it out right after it finishes.
Okay.
All right. You guys see the PowerPoint presentation?
We do.
All right, so this is the view from UT, and you can see this glass facade carrying across the what we're calling is this pier extending out. It mimics the dimension proportionality of the existing building. And one of the things that Weissman Freddie has worked with Hygis through, for 10 plus years has been this idea of utilizing the facade and surface treatments of the glass to instill different readings and different expressions of the building. So here on the right-hand side is our Penn Nano project at University of Penn, where there was an acid etch and a frit pattern utilized to create this depth in the glass. Some similar techniques that we'll be sharing with you guys today. We've gone through a series of glass sampling process. So we've worked with a lot of different manufacturers, getting different treatments, studies, coatings. We've narrowed down what we think are the most appropriate coatings, both from a visual but a performance side. One of the things that we've put in our spec that we find is important to successful projects is to be available to visit shops, to view initial runs of glass and make sure that everything is meeting the expectations and the standards, so that this is a component of our involvement that we'd want to work with you on. We'll go into it some, but in all of our projects, we think that the use of a visual mock-up, there's both the performance mock-up this project will require for being tested for impact, but just for materials to make sure that the manufacturers, before they do their final runs, that everything's in alignment with the expectations of the owner and the architect and yourselves. So when we look at the building from the Riverwalk, you guys can see that there's this horizontal metal band that tracks the bottom of the curtain wall and the top of the curtain wall. And then we have what we call wall type 3 is embedded between those two bands. Those bands of aluminum match up with the existing building's edges. Below that and above that are wall type 1 systems, which are this typical YKK system that we used in the renovation, off the shelf kind of pre-tested systems. The intent is to use the same glass coating so that you're not getting this kind of variance in what the color rendition or any of the components between the two different facades. We want the buildings to be unified, in that sense. So the ground floor and the rooftop fourth floor event space are all encaptured with this pre-tested system. And then what we describe as A up here is the roof canopy, which is another metal that's of similar color and tone to these horizontal bands that we're talking about. The glass itself, the wall type 3 glass, and which will turn into the wall type 4 metal panels on the north side of the building, they have a direct relationship with the structural requirements of the building and the structural truss design. So you can see that as this truss marches to the west towards the river, the curtain wall is bifurcated into two different sections, an upper and a lower section. The upper portion is where we're looking at doing more detailed architectural expression using a banding effect with acid etch on the number 1 surface. And then in the lower section, which is the more transparent, it's where the people in the museum will actually be able to approach the glass. That's where we let the transparency be much greater. And in this location, the only surface treatment would be a bird safe fritting that we would be like a standard Guardian type bird safe fritting that would be applied. So what you're getting in this kind of effect by having this acid etch applied to the number one surface versus like the number two, is that you're getting this matte quality that the glass is kind of, it'll kind of distort the way that your eye kind of registers the glass. So you're going to have this relationship of a very shiny, transparent lower section against a matte, which will always be playing against your eye, how it's visualized. And so as the building, as it turns along the north side of the facade, we're trying to instill that same kind of visual relationship in the metal panel. So one of the things we'll talk about today is this surface treatment of the metal panel as it relates to the glass. So as we have a matte finish on the upper portions of the glass, we're talking about having like the relationship of a very matte versus reflective metal panel. And we're not talking like a mirrored metal panel. We're talking about like a polished one that has higher reflectance than typical. Miranda, do you want to speak to anything on the metal panel that I missed? We can dwell on it more later.
No, I think you I think you captured the concept of just that relationship between the glass and the metal panel and the continuation of the pattern. Maybe one thing to note is that at the fourth floor where it says E up there, that's needs to be perforated. We can get into that later. But we have exterior louvers across there, so we'll need perforations on that facade.
Yeah, this E is a lot of manufacturers make these louvers with these storm louvers with perforated panels in front of it, and that's generally the concept. We've done it in other projects where you can either buy it straight from the manufacturer or it can be an independent system. But it's a nuance that we can certainly get into. So then this is looking at this soffit condition. There's a lot of soffit with both the underside at the lobby space and the soffit that's extending over towards the river, and then obviously the soffit on the fourth floor. So this building is really a lot of times the material turns on the underside and it becomes a dominant element to the experience. We've worked with our lighting designer, finding thin lights that can actually fit in the joint sizes of the manufacturer's metal panel systems, so that it's a relatively simple installation and clean and straightforward opportunity. So that's what you see in these lights themselves. The wall type 1 is here on the ground floor. Sorry, did somebody have a question?
Yeah, just those lights. So that's usually the structural element of those metal panels under there. So you're intersecting the structural element with the lights.
So these are a hook and pin metal panel system. So the attachment doesn't have to be at the edge condition of this is a plate system versus the folded edge detail. The folded edge metal panel is the D version. And we can show you some of those details in just a second.
Okay.
So there's two types of metal panel. There's the gray, which we're showing here to match the existing museum. That's level D. And then we've got this metal panel that's plate that's above.
David, can we go back to that last one
Sure.
for a second? I just want to make sure I'm clear where you're showing B for the reflective metal panel. The bottom band, I know we've talked about it in different ways. Is the intent for that also to be the reflective metal panel and then turns and becomes the soffit?
I think this is a clerical. It's actually inverted. The matte is on the underside and the bands and the reflective. So where we have B, it's actually A. So this is a clerical mistake on our part.
Oh, okay, it's just flipped.
Yeah. It's just we'll double check. It's definitely, I'm pretty confident that our set is correct and that this is just a graphic that we made for the museum.
Okay, yeah, I mean, because I also, wanted to make sure that, because at one point we talked about the band being more the return edge
That's
as
right.
opposed to the plate.
That's right.
So is that still
Yeah.
the intent?
Yeah, let me do this one last slide. So this will be this is the soffit I was describing on
Mm-hmm. Okay.
on the west side. So you've got as I said, the mat is here, um, showing the full scope of the project. And then we can jump into the drawings to get more detailed. Oh, and yeah, and this is the last, from a building enclosure standpoint, the other is this fourth surface, the ground plan on the rooftop and on the second floor, or there's this paver system roofing below. And this project marries up with the existing building's exterior terrace, and you can see it kind of walking out towards University of Tampa. Okay, so I've got our drawing set up. Big picture wise, the way we set up our set is the 300 series is like building sections and building systems. So for the building enclosure, so exterior enclosure system details. So the 310 series is all of your wall type 1 series. Your 320 are all your wall type 2, and then 330, et cetera, et cetera, et cetera. We get into like we go through the building enclosure details. We have a system drawing for the paver system for the plazas at both the second floor and at the rooftop. And then once we get through the 300 series, we jump up to the 3-inch, 6-inch full scale details. And again, we follow the same logic. So the 410 series are all the system specific details for the wall type 1. So the hope is that it's easily navigatable. So when you get to like wall type 2, you can go to 420 and that's your set of drawings, your details. So yeah, so that is how we set up the building enclosure set of drawings. Maybe I'll start with the 330 series, so we can start to talk about this relationship of the glass system and the horizontal bands that are above and below it, and how they integrate and become one system, and the importance of it. And I don't know, Matthew, if you want to jump in and discuss how you envisioned it, we can start there.
Sure. Oh, yeah, I can jump in now. Um, yeah, essentially this is the wall type 3 system, the main kind of glazing system that David has introduced. It's a steel and glass system, so it's a bespoke steel T system that is toggle glazed. Yeah, I don't know if you want to go into a detail or zoom into a plan. So the steel T was actually sized to be, relatively slim. I think that's, part of the architectural intent. And then you have glass glazing that is structurally silicone glazed to an aluminum cassette. So this would be done, in the shop, in the factory, shipped out to site. And then the glass units are set and toggled into place, and you can kind of see this toggle here. Yeah. The other component to it is the nib, which kind of divides the lights and provides some relief from having like a larger silicone joint. It's a small aesthetic detail, but it does kind of make a difference in the final product. And the glazing itself, is intended to be an impact rated glass. The sizes are a little bit larger than what's typical commercial sizes for impact rated glass. So you'll notice that the glazing has is a little bit thicker than a standard, large missile impact radiant glazing. I think a component to that is being just a tiny bit conservative so that we're confident that the system would pass the impact tests, project specific impact tests. And another unique thing that I think some suppliers might call out is the fact that the laminated glass is on the exterior. And I think the intent here is to kind of have the thicker piece of glass on the exterior because it should help with the flatness. So this would be like 2 8mm sheets, I believe. And I believe this is either an 8 or a 10mm sheet. So 2 5/16 pieces of glass on the outside and a 3/8 or another 5/16 piece of glass on the inside. A lot of large missile impact systems will have the laminate on the interior. And the idea is that when you shoot it with the large missile, the outside piece of glass is kind of sacrificial, so it actually breaks away. And it absorbs a lot of that energy from the impact. And then you have the laminated piece of glass on the inboard side. So here we just have a little bit more robust of a glass makeup with the laminated on the exterior to kind of preserve the flatness of the IGU, both for flatness during fabrication, but also flatness due to any sort of pillowing that might occur on the project. So pillowing would occur from climatic loads, changes in temperature, etc. The steel T system is it's relatively slim, and currently it is thought of as a base loaded system. So the dead load is actually being taken at this level here. The difficulty with base loading the system is that the T-mullions are quite slim, and so they're subject to compressive forces or buckling. There is currently the plan to have at column lines a brace, so it's not necessarily supporting the member for dead load or wind load. It could actually be designed to not support the mullions for wind load. It's actually just supporting it. Yeah, I don't know if you have a plan of it. Yeah, that's okay. It's supporting it for buckling in its weak axis. So yeah, that'll work. So it's supporting the mullion, from wanting to buckle in these directions. But it's allowed to slide up and down, and potentially it could be an oversized hole too that allows it to move under wind load if need be. And the intent is that this connection is actually bracing the mullions in between the column lines as well for buckling. To get away from this, I think the other approach that might be offered is hanging these mullions from the roof, but that is not currently what's been coordinated in the details structurally, hanging from the roof beam. The advantage of base loading it is when you transition kind of from the standard system to the system on the terrace, the system on the terrace will want to be base loaded so that there's not any issues with movement around the door openings. So right now the doors are just kind of set right into the system. If the system were hung, it would probably require a door portal of some sort that can accommodate the vertical movements.
Yeah, and to that point, MKA has all of their modeling and all of their sizing has been coordinated with the assumption that this is base loaded so that the load is transferred at level 2 rather than the rooftop. And so it's just taking some of that load out of the truss that's going up to the roof.
Yeah, Matthew, we should also mention that the diagonal here is a true mullion
Hmm.
and the glass lights are divided at that point.
Yeah, that's right. So the diagonal is a true divided light. Which will make for, some special joinery in these locations. But you'll see that Weiss and Freddie's, gone through this exercise of kind of detailing how those nibs, those exterior aluminum nibs are kind of terminating.
And, generally there's a slight, just because of the shape of the building, there's a slight difference on the north side of the spacing. But, within a bay, your glass sizes there's some common elements, right? So these are all the same size, and then these are all the same size. So it's not like it's totally, each one is its unique piece. Within the south facade, the west facade, the north facade, there'll be these common triangular pieces throughout. We've tried to take a first pass on the assembly process of how, Matthew is describing these nibs getting installed, this glazing plate, and then also looking at in further detail, like how these triangular mullions actually integrate at the corners. So these are all like little studies and how the tabs are developed. It's a first pass, and we're obviously every contractor will have some different approaches to it. We've spoken to a few people and a few different manufacturers through our process of design, so we've gotten some feedback, but none of them are proprietary. This is all kind of, from the design side. Matthew, since we're here, we're at the corner. Do you want to talk about the transition from the wall type 3 to the wall type 4 metal panel?
Yeah, sure. Right now the zone is detailed in a way that essentially the vertical mullion kind of steps in and continues down, and it allows for, that's okay. It allows for the kind of spandrel bands of metal panel to be kind of hooked onto the facade mullions. So it's kind of doing double duty when they're installing these mullions. They're also providing the framing that's going to support the metal panel below.
So the mullion gets notched, and we've detailed where we've shown it in elevation, it gets notched and it comes all the way down. Something like that.
Mm-hmm. Yeah, I don't know if we have a plan detail as well that kind of shows the.
We do. Okay, so. All right, so this is the typical. All right, so that's the lateral support. Then just directly below it is when that mullion gets reduced in depth, and this is the anchor at the slab edge.
So the concept here is that there's a insulated metal panel that kind of gets glazed in, captured, and then there's a hook and pin system, in each vertical mullion where the metal panels will hook onto. But I think this emphasizes, the concept of this, continuity between the glazing contractor and the metal panel supplier. And having a consistent, metal panel across the whole project.
And then just a quick question, like on this transition from the vertical face, that's integral with the curtain wall, which is in the curtain wall.
Oh, your audio cut out.
I think they froze.
Uh,
I'm gonna go tell them they froze. I'm like feet
Specification,
away
and
from
then,
the.
and this was kind of
Mike.
looking at the soffit at the lower end of the page where, I know.
This machine.
This stinks, guys.
You're back now, Mike. You're back now.
Okay. I can't unmute though. Can you unmute on yours?
We can hear you. You're unmuted.
Oh, you can? Okay.
Yeah.
I was looking like, and so like if, for example, the soffit condition where the vertical face beneath the curtain wall is the metal panels that's within the curtain wall specification. As it transitions down to the, and sorry, I'm on the left-hand side of the split screen. Yeah, right here, where it transitions down to the horizontal soffit, does that change to the Division 7 metal panel specification product, or is the intent of that to follow the same product as the curtain wall provider? I'm just trying to get my head around the different aspects of what the curtain wall guy is going to have versus the standalone metal panel person from a design intent.
From a design intent, I think we want the whole, like, basically, I'll go back to the rendering real quick. Everything that's this like aluminum, the bands, the soffit, the metal soffit up the top, like if these are all the same similar finishes across, I think it's really just the E, which is the metal panel on the ground floor, and the metal panel that's dark up here, which is the 700, the 7 series.
Okay.
Everything else, we think there's a benefit. Even the coping of the at the top of the wall is to come from the curtain wall manufacturer. And like you guys, we went back and forth the question of how you include Zaner and Pole or other metal panel people into that package is kind of how that gets nuanced together.
Okay.
Yeah, we'll definitely make the scope that way.
And it makes a lot of sense with that coping too. That way, basically they own everything from that slab edge out from a waterproofing standpoint, and that slab edge curve inward is the roofer from an envelope standpoint.
And you don't
So
get
that
people
makes
pointing fingers
Yeah,
at each
right.
other.
Yeah.
Yeah,
Okay.
I mean, just to add to that, I would say the idea of E, specified separately being a separate contractor, certainly a possibility. And if there's a cost savings to do that, we'd want to kind of understand that, the other way is looking at if there is, value when you're talking to the curtain wall contractors of including all of the metal panel cladding in their scope.
Yeah.
Could we look at that transition E to A and the section cut either at the top or at the bottom?
You're saying from E to, oh yeah, sure.
That's
Gotcha.
not better.
Let's talk. So this is the typical, on the left-hand side is the typical wall type 2 metal panel. I'll bring it up on the side what the details look like. So you'll notice it's a typical back cut aluminum panel that gets, at the joints like you guys mentioned. And then acting as a rain screen with a gypsum with, I guess, the waterproofing applied to the exterior sheathing. And then as you go up, so section 320 here, so there's a small soffit, small return section that will happen. And
so
that's
does that in the return, and the metal panel guy does the vertical.
I'm looking for the view.
this is the north side, so it's a very shallow return on the north side. There's not much room on the project site to actually have a larger overhang. And we'll in this sheet 441, you'll see that we start this section detail where the return happens, how it meets the slab edge, and all the way up through the building, a typical joint of this plate panel. So between the upper bands, so there's the horizontal bands that cross the whole site. In between that is this true plate panel. But we've been looking at how the interaction occurs between the two and whether the bands should be folded back like so at the north and the bottom. So it's just a minor detail. We can get into it. It's nothing too crazy here. And then let's see, so yeah, we have coping details for it. And then this particular detail right here, which is the section at the screen wall. So if I go back to our PowerPoint, the mechanical well does something like this. So this area is where the new air handling units, the chillers and the sorry, not the air handling, the chiller units and the generator exist. So this is a screen wall, and then on the back side, we have a coping detail of how it turns and becomes the panels on the inside, and that's what this detail shows, is the coping coming over, and the metal panel flashing, and the new waterproofing. That's the roof type 2A at that spot.
Hey, so have you guys considered, yeah, because I thought of that, look, and you brought it up, but the inside of that chiller yard is metal panels. From a V or value engineering standpoint, is there consideration of just making that stucco or something?
Can the general public see the inside of the well if you're spending all that money on that metal panel?
There's a residential tower right next door that will be able to look down into it. The garage could look down into it.
Okay.
It's, I mean, it's it's to be discussed for sure, but we'd prefer to maintain the level of finish, but let's see where we're at.
Part of that is, setting those chillers, working all that equipment, and then just protecting the through construction, make sure we don't get
Yeah.
dented. But,
Okay.
something.
Let's see, what else should we target?
Well, look at the roof canopy.
Sure, there was one other thing I figured after we go through some of these details, we can dive into the specifications and specifically talk about that. So the roof canopy, this is the 470. So let me set this up the same way.
Go to the wall sections. It has like an overview.
Yep. So here on the left-hand side is the idea that you have your event space that's enclosed on the right-hand side, and then you've got your canopy, which is simply supported through a series of columns, and this knife edge detail at the edge. We briefly spoke about this in the structural meeting, about how the steel was designed in a pretty simple manner, with a bent plate at the edge of it to accommodate this shape. The metal panel, similarly, we're looking at trying to create like an end cap to kind of create the streamlined effect at that edge, and then series of typical joints all the way around. Miranda, do you want to speak to anything specific about the coping or anything?
Sure. So as you can see, it's detailed similarly to wall type 2, just a typical back cut folded plate system. So, I mean, those can be pretty similar. We've already sort of yeah, as David's showing there. And at the canopy side, you know, we don't need any insulation where it's not above occupied space. We do have it turning down at the edges just for, you know, better waterproofing. And we have already added a joint on the top surface, but that would be a closed sealed joint. But yeah, I think that's it. Oh, and this section is showing above occupied space. So part of it does go above occupied space on the north side. And we have a shorter soffit section there as well. And this
Similar-
is also where the perforated panels are on the wall type 2, just below there. Yeah.
So this is where the building's intake is occurring for to service the air handling units that are on the second floor mezzanine. Yeah, I wasn't planning on really getting into this too much, but I will bring it up. One other small component to the project is the museum's looking to do like an all glass vestibule coming out of their existing museum on the second floor. It would be fairly easy to miss. Let me show you in plan. So on the second floor, that terrace that we're linking up with, they're looking to add a new vestibule and replace the existing revolving door. So, you know, from a code standpoint and from like an accessibility standpoint, the whole plaza is accessible through these new doors that are being added to the terrace. They just prefer to enhance it, you know, from an experience standpoint. So this is one of the last things we added to the project, but it is a component that's that they're interested in moving forward.
Yeah. Is that like a storefront system or curtain wall system in that vestibule?
It's like a steel framed all glass system, fairly, I can pull up the details of it. It's not, so the intent is there's some chopping out of some existing concrete to set the new frames. It's just a tube steel frame construction with a mounting plate at the bottom and the frame around and then glass set in place. This, you know, technically, because the building enclosure, the building is hurricane proof, right? Impact resistant. This exterior vestibule isn't having to meet that requirement. So the sizing of this, Matthew, correct me if I'm wrong if I'm speaking out of turn, but the sizing of this is not specifically impact resistant, although it might pass.
Yeah, that's right. That the glass isn't intended to be impact rated in this zone because it's part of the vestibule and not the building enclosure.
So, okay. The next thing I wanted to talk about, if you guys, unless there's some details you guys want to focus on, I was going to talk briefly about the spec and then we can go back and forth. So to start, so through the design process, we reached out and had varying conversations with these 7 glass manufacturers and these 2 metal panel manufacturers. I don't know, Matthew, if you want to describe your conversations with them and their interest levels, or how you want to kind of pass on some information.
Yeah, I mean, just to speak, I guess, candidly about our previous coordination with these contractors, I think Sele was previously approached, and at that time when they were bidding the project, I think they understood the,
Matthew, David, do y'all mind if I interrupt? So we planned on, maybe we could talk about this after we go off record. Because
Okay.
we planned on sharing some of these videos to some of the bidders, because we have some input as well.
Okay,
Do you mind if we wait till we hit stop record?
sure.
oh, yeah,
Okay.
absolutely.
All right.
Awesome. Thank you. I'm
So,
sorry to interrupt you while you were
Yeah.
talking, but
No,
no, we
thank you.
appreciate that. Okay, so these are the manufacturers that we've had continuing conversations with. So they're all, at some level, we've had those conversations. The other thing that I wanted to point out too was in the specifications, we list these glass coatings. And one of the things I mentioned earlier was the importance of the wall type 1 coating being matching the existing buildings so that we don't get like a lot of difference between the two coatings. You know, everybody will say like, hey, we have the same performance value, this, and this, but when you get the coating in the same light, like one will be more blue or purple, you know, so there's always some difference that occurs no matter if the values match up. We go through and identify the treatments that are going to occur on each one. And, you know, so like for glass type 3, we identify this acid etch and this ceramic frit. We identify what we found to be the most appropriate basis of design for the coating itself. And Matthew can speak at length to the performance requirements that the spec identifies. We don't have to get into it today. The last thing I wanted to talk about was the mock-ups. This, you know, we have a couple of mock-ups shown at the end of the drawing that we think are beneficial for the manufacturer to conduct and for the team to evaluate. One is like a typical tabletop mock-up of just the mullions intersecting and how these components interact, like getting that worked out through a small mock-up we think is beneficial. A small visual mock-up, which, has the relationship of a glass and a metal panel side by side, so that we can see, make sure the finishes are appropriate, and that, you know, this would be an opportunity for them to hone the relationships of the banding with the glass above. And then lastly, we diagrammatically indicated that in some fashion, the manufacturer is going to have to create a performance mock-up to pass the Florida impact resistant requirement. So it's like potentially this like corner element of the project they might have to fabricate. So we wanted to, you know, we know you guys are starting up, and the idea of developing your schedule, we find that these can oftentimes get pushed back too far in the project or not be of use. So we were trying to forefront the issue for you guys so that if the schedule can, just like you're talking about in other trades, like maybe bringing people on to advance these so that they can get resolved is helpful. Okay. Anyone? I want to leave it open. We can talk anywhere you guys want to go.
So on that, the mock-up, and obviously performance mock-up would be done in a factory setting. And I apologize, I hadn't got into the deepness or deep into the mock-ups, but are you envisioning something like an on-site or something, a mock-up in a facility? If this is all one person's component systems, or do you look for interfaces between, you know, the metal panel people versus the curtain wall? And we could work that out. I mean, it just kind of, how do you visualize it?
I think, and John, you can correct me if you disagree, but I think the ideal scenario is that this was built on site with the lighting that the museum is going to have. You know, so like every place in the world will be slightly different. So ideally, that's the starting point. But the second tier is if it is at a factory, but the materials should all be, if this is Poles or Zahner's metal panel, they should go to the glass manufacturer's site.
Sure.
Yeah, I think that's right. And of course, differentiating between the performance mock-up and the visual mock-up, you know, sometimes they could even be combined, but you know, some of the contractors on the list for the curtain wall, you know, for instance, for performance mockup would have the ability to test at their own facility. So there may be some flexibility or options as to where, you know, both the visual mockup and the performance mockup could be performed.
Yeah, and I'd say that, you know, alternatively, if the visual mockup, you know, ideally it's happening on the project site, but if it's not possible, we've seen oftentimes that there's a site secured near the project with similar lighting conditions, the similar sky dome, that the visual mockup can be viewed.
And like this particular, you know, the fact that there's the coping and there's the horizontal bands, like they might not need that for the glass performance impact testing requirement, but maybe if they are building all of this in their shop to be tested in their shop, maybe there's a capacity to combine the visual mock-up to be a more expansive performance mock. You know, it's like it's blending the two, making them, but it's also like timing, like if one has to happen so much later and you can't make decisions on final finishes, like then it doesn't become helpful. So it's just kind of looking at how you guys think that will fall in your schedule as well.
I guess one of the questions on the visual mockup side is, you know, David, to the point of the glass makeup and being in a position to make final decisions on the glass in order to place an order. So, you know, I think if that's happening at the visual mockup, you want to try to do that earlier in the process rather than later.
Any other system design questions you guys have that you've come across in your looking in the documents?
Not yet. Not that I can think of.
Yeah.
But we're
Not yet.
we're still absorbing it all.
knee deep.
Yeah.
Starting to write the scopes.
It's okay. We're here when you're ready.
Okay.
Evan, Drew, Gary.
Yeah, I do see like in the specs how clear it is with like the slab edge, fire stopping being required by the curtain wall guy, and really just detailing out kind of every piece of these details in the specs is very helpful. So,
And impressive.
yes.
Well, I think within the curtain wall specification section, that's really the intent. This is typically how we would write the specs so that it's aligned with the expected scope of the curtain wall contractor, so that from a coordination standpoint, you know, from an inspection standpoint, enforcement of quality control issues, all of the materials and components that would be part of the curtain wall scope of work are in one or are in that one section.
Yeah, that's what I'm saying. It's great. Thank you.
Yeah, no, we're good here. Just getting into it ourselves. It doesn't warrant questions from us quite yet, but today was so helpful. Like you said, we don't get this level of and awesome information up front like this. So today helped a ton already. So we're more excited than we were before.
Challenges, right?
Yeah. Oh yeah, we're excited.
It's awesome.
David, do you want to take us off record?
Yeah.